Hey everybody, Coop here with Random Acts of Tech, and today we are working on a project that is a very small part of a very large project. This large project is about midway through, but it can't really continue until we get this side project done. If you want to see a little bit more about this larger project, just click here. This is my blog. There you'll find a chronicle of the larger project from the beginning to where we're at right now. So today, we are fixing this laminator. I'm sorry, did I say fixing? Breaking is what I meant to say. This laminator is normally used to laminate sheets of paper and cardstock and things like that in plastic laminating sheets. That's not what we wanted to do. What we wanted to do is to make this out of this. This is a copper clad board. This is a custom PCB circuit board. We're going to use a method known as the toner transfer method to create this. This method takes a laser printer to print toner onto magazine paper, like this. Yeah, cigars. Why not? Once we've printed toner onto the magazine paper, we will then attach the magazine paper to the copper clad board and iron over the top so that it heats up the toner and transfers it into the copper clad board. That's the easy way of doing things. Since I never like doing things the easy way, we're going to complicate it. We're going to make it to where we eliminate the iron altogether and we pass the copper clad board with the magazine with the toner printed on it through the laminator and come out with a nice, consistent product. I have already modified bits and pieces of this machine to get it a little bit hotter than it normally gets. The process that we're doing requires a little bit more heat than a standard laminating process would. So I've done some things in there which you can see on my blog. However, we're still not getting the results that I'm looking for. So today we're going to go in there and we're going to tighten up the rollers that squeeze the copper clad board and the magazine paper together to see if with the increased pressure along with that increased heat, if we can get a nice, clean, consistent result. So we're going to dive in here and see what we can break. Now that we have this thing open, you'll see kind of what I've done before. Is I've taken the pieces of aluminum that are on the top and they're on the bottom that were wrapped around the heating element. There's a heating element on the top and a heating element at the bottom. It had aluminum wrapped around to keep some of the heat off. I have cut the bottom one and flattened the top one so that there's no heat being blocked from getting to these four rollers. So what I'm going to do now is I'm going to go underneath and I'm going to see if I can tighten the tension bolts that hold these rollers down and create tension to see if I can increase that tension. Now, I needed to open it up so I could see where the screws were located on the tension bolts. Now that I've opened it up, I can tell that I don't actually need to take the cover off to get to those screws. They're here, 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 and here. Those are the four screws that tension the two rollers. So if you find yourself needing to do that, you don't even need to take it off. You can just turn those screws without taking the lid off. All right, so now what we've done, we have printed our pattern onto this magazine paper. I took a shot of it earlier. I then have attached this magazine paper to the copper clad board, just applying some tape. What we're going to do then, we're waiting for this to heat up. We're going to pass this through, back and forth through the laminator. This laminator is an Apache laminator and it's model AL13P. I went with this model because there were several people who have modified it before who have used it to do this sort of thing before. And so it was a suggestion on the internet, and when the internet speaks, I listen. The one problem with this, it goes pretty quickly back and forth. We don't need it to go that quickly. Luckily, they have included a REV button right on the laminator, and that changes the direction of the feed. So what we're going to do is we're going to feed it through one way, and when it gets to the other side, we're going to stop it and feed it through the other way. If we let it go all the way and have to take it out and feed it back again from the front, it's going to lose heat on the way out. Not only will the copper clad board lose heat, but the rollers on the inside will also lose heat. So we're going to try to keep it inside going back and forth for a few minutes to try to get a nice, even, solid transfer. Just run this through several times, and it is extremely hot to the touch. So now we're going to unwrap it and see, hopefully, if we're left with a nice transfer of toner. So. We're looking good so far, but we've got some paper that's stuck behind. So what we're going to do is we're going to run water over this to loosen up the paper and see if we can get the paper away and see what it looks like. So, as you can see here, this is by far the best result that I've ever gotten. So tightening down the rollers on the inside definitely had an effect. However, it's not perfect. I want it to be perfect. I'm going to try one more time. I have a fresh magazine here printed out. And I'm going to try one more time. I'm going to leave it in a little bit longer than I did before and see if that helps. And also, before I start ripping any of the paper off, I'm going to go ahead and soak it in water so that it releases from the toner, so that I don't run the risk of maybe accidentally ripping some of the toner up with the paper. So we're going to try one more time and see how that goes. All right, it's finished. We have a first time and a second time. As you can see here, the second time that I just did, where I left it in just a little bit longer, and I ran water over all of the magazine paper before I ripped any of it off, it came out absolutely 100% perfect. There is not a single gap in the toner traces. It is completely solid all the way through, even around the very small circles. There's no toner missing, which is absolutely key, because if there's any toner missing, then that could leave a gap in the copper. What's going to leave a gap in your circuit, which will ruin a lot of things for your life. So there we have it. We modified it to increase the heat. We moved the aluminum out of the way so it wasn't blocking the heating elements. We then tighten down the rollers. Now keep this in mind. When you tighten down the rollers, if you tighten them too much, this will not fit in. It will stop. It won't roll. It won't engage the motors to make it roll through. So you're gonna have to play with it a little bit. You're gonna have to tighten it up, and if it doesn't fit, you're gonna have to loosen it a couple of turns, which is what I had to do. But once you get it right, you can easily, consistently make nice, clean, perfect traces. Now that this is done, what we're going to do is we're going to cut this in half, take just the good part, and we're going to etch all of the copper that's not covered in toner away. So all we're left with are these traces that we've laid out in copper. Everything else is going to be plastic. And then we can move on with our project. All right, folks, there you have it. The next video, we'll be etching this copper away and moving on. So until next time, make something.